Yes. Chemistry paper 3 practical 2015. I want to look at 2015 today and see what they were provided with. 2015. You are provided with 2 grams of substance A labeled solid A, solution B, which is 0.05 molar hydrochloric acid, methyl orange indicator. You are required to determine solubility of substance A in water, relative formula mass of substance A. I want to take you procedure 1 because we need to understand here for us to go to procedure 2 because they are related in one way or the other. Place 200 centimeters cube of tap water in a 250 ml beaker and keep it for use in step 4. Actually, practical is to use just to listen and execute the instructions. Now this one, we keep it for Roman 6. Place all substance A in a dry boiling tube. That is the next thing. Using a purette, measure 10 centimeters cube of distilled water and add it to the substance A in the boiling tube. While stirring the mixture in the boiling tube with a thermometer, warm the mixture using a Bunsen burner until the temperature rises to 65 degrees Celsius. Stop warming the mixture. Allow it to cool while stirring with the thermometer. When the temperature drops to 60 degrees Celsius, start the stopwatch. Place the boiling tube in the beaker with tap water prepared in step 1 above. Continue stirring and record the temperature of the mixture after 2 minutes. Then thereafter record the temperature of the mixture after every 1 minute interval and complete the table. This is my way. I want us to retain the mixture with the thermometer inside for use in procedure 2. So I want us to understand here. What did we do? We took solid A, put it in 10 centimeters cube of water, and it is dissolving using the temperature here. I want just to give you the values so that you can draw that graph at home. So the values, this one, I call it 6.0, 36.0, 30.0, 29.0, 27.5, 27.0, 27.0, 27.0, 26.0, and then 23.0. So draw that graph and you will see, you will be able to answer the question thereafter. Procedure 2. Using a panel, transfer all the mixture obtained from procedure 1 into a 250 ml volumetric flask. Rinse the boiling tube and the thermometer with about 20 centimeters cube of distilled water and add the rinses into the volumetric flask. Repeat rinsing 2 more times and add about 100 centimeters cube of distilled water in the volumetric flask. Shake until the solid dissolves. Add more distilled water to the mark. Label this solution A. So up to that point, I want to help you understand one thing, that from procedure 1, we add 30 centimeters cube of distilled water, dissolving solid A. So we are transferring 30 centimeters cube solution which is containing solid D into a 250 ml volumetric flask. So here we are going now to prepare solution A, which is 250 centimeters cube solution A. Very important to understand that. Leave around the more words, the procedure there, but the final thing we have done is we have prepared the solution A, where in 250 centimeters cube solid A. Thank you. Fill the puree with solution A using a pipette and a pipette filler. Place 25 centimeters cube of solution B into a conical flask. Add drops of indicator provided and titrate using solid A. Now we are now titrating solution A against solution B, but we know what is solution B from our from solution B is 0.5 molar hydrochloric acid. Now that one we know. So A is going to react with B in procedure 2. So I hope you must understand the procedure. This thing here. Which solution do we have in the puree? Which one are we pipetting? We are pipetting 25 of solution B. Solution B, which is HCl. And then the solution which is in the puree. The solution in the puree, because we are told fill the puree with solution A, the one we have prepared. So the volume we are going to get here, the average volume is for solution A. That one is important for you to understand. So let us use this average volume. We want to use 30.8. 30.8. Our initial, I want to say to can it is okay if you start at 0.0, 30.7, 0.0, 30.7, 0.0. Do the arithmetic. 30.8, 30.7, 30.7. Because I can see this one are the same, because I want very accurate answer, then I will do the average with the 2, leave this one outside. So the average is 30.7 plus 30.7 divided by 2, because I have done on with only 2. If I did all of them, I will divide by 3. This one will give me 30.7 centimeters cube. That's my average. Determine, remember, calculate the number of moles of hydrochloric acid solution B. Very easy. Why is it very easy? We know the molarity of solution B, 0.05 capital M. This is solution B. But we know, what does this mean? This means that 0.05 is the number of moles in 1000. But what was the volume of solution B used? We come back. Using a pipette 25 centimeters cube of solution B. So we will ask, this is 25 is the solution that was used. So we ask 25 centimeters cube will contain what number of moles? So this times this divided by this. That one will give you 0.00125 moles. Right, given that 2 moles of the acid reacted with 1 mole of solid A, calculate the number of moles of substance A used. Now, substance A, we have been given that A to B. This is substance A, this is the acid, HCl. So we have to do that given that the 2 moles of the acid B, so 2 moles of the acid reacted with 1 mole of A, 1 mole. So the ratio is 1 of the acid and to the base is 1 to or to 1, whichever way. So calculate the number of moles of substance A, but we know the number of moles of B. B is equal to, what will it be? 1. It will be a half. So moles of A in 30.7 centimeters cube equal to a half times 0.00125, which is going to give you 0.000625 moles. Moles. Calculate the concentration of solution A in moles per liter. Concentration of solution A in moles per liter. Moles per liter, that one simply means morality. Morality is the number of moles in 1 liter. So we are calculating morality. But what do we know? We know this. We know that 37.7 grams of A contains this number of moles. So what will 1,000 contain? We say that 30.7 centimeters cube contains 0.0000625 moles. Then 1,000 centimeters cube of solution A will contain what moles? So it is 1,000 times this divided by this, and it is going to give us 0.02036, capital M. Now this is morality. Because it is morality, I want us to give it to 2 decimal places. 1, 2. Because this one is a 0, let us take it to 2. If it is morality, always try to make it up to 2 decimal places. 2 decimal places, it is fine. So this one we will truncate and say 0.02 capital M. For morality, it is acceptable. We use 2 decimal places. Okay, because this one can make a very big difference. This one, a very big one. So we round off. Calculate the solution, concentration of solution A in grams per liter. Grams per liter. That one is very easy. And why is it very easy? We go back to what we were provided. We check what was the mass that we are given. So we were given the 2 grams of solid substance A. We were given 2 grams. But remember, we have prepared substance A or solid A. We have dissolved it in 250 centimeters cube. So we want mass in grams per liter. Grams per liter. So if 2 grams is in 250, 1,000, which is 1 liter, will be what? That's what we want to do. Two grams was dissolved to form 250 centimeters cube in the volumetric flask. 1,000, that is 1 liter, centimeters cube, will contain how many grams? So it is 1,000 times 2 divided by 250, which will be 8 grams per liter. 8 grams in 1 liter. Next question. Calculate the relative formula mass of A. We want to calculate RFM, relative formula mass. Always remember this triangle verse, which says that morality RFM mass in grams per liter. So we want to calculate RFM. How can we calculate RFM? RFM is equal to mass, so RFM equal to mass mass, you hold this one on a constant, mass in grams per liter divided by molarity. Mass in grams per liter, we have grams per liter, 8. What was the molarity of solution A? Here it is. Concentration molarity is 0.02. 0.02. So you use your calculator and you get it is 400 grams per mole. 400 grams. So the RFM is 400. Quickly, let me take you through the qualitative part of it. We have been given solid C. So let us see. Place all solid C in a boiling tube. Add 15 centimeters cube of distilled water and shake until all the solid dissolves. Use 2 centimeters cube portion of the solution in a test tube for each of the following tests A up to F. A. Add aqueous sodium hydroxide dropwise until in excess. Let me give you the observation that was there then. White PPT insoluble. White PPT which does not dissolve in excess. I have always told you, once you are adding sodium hydroxide, a white precipitate is formed which does not dissolve in excess. Then be sure magnesium ions, barium 2 ions, calcium 2 ions are present. That one you are sure of that. Next, add aqueous ammonia dropwise until in excess. Aqueous ammonia until in excess. Now, this time round there is no white PPT. No white PPT formed. If there is no white PPT formed and we suspect that these ones were present, this one forms a white precipitate with ammonia. This one forms a white precipitate with ammonia, but this one does not. Calcium ions does not. Therefore, it means that calcium 2 positive is present. C. Add 2 to 3 drops of solution D. Aqueous. Add 2 to 3 drops of solution D. Aqueous sodium carbonate. Retain the remaining solution D. Retain the remaining solution D for use in question 3. Right. So we are adding aqueous sodium carbonate. Sodium carbonate. So sodium carbonate is so we expect when it goes there, if there is calcium, it will form calcium carbonate. So here, what was the observation? White PPT. So if a white PPT is formed and there is no effervescence, actually there is no things of acid, because from here we have not said there was an acid, something like that. So here we are going to just repeat that 2 positive are present, calcium. Because the carbonate will form calcium carbonate, which is a white precipitate. That is the knowledge we are talking about. We are adding dilute HCl, 2 drops. And then, remember here, we expect effervescence. But why are we expecting effervescence? If there was a carbonate, isn't it? If there was a carbonate inside there, because we have said calcium carbonate, it will form effervescence. But in this case, there is no effervescence. Oh, there is no effervescence. If there is no effervescence, it means that the carbonate, the sulfite, are absent. The carbonate and sulfite are absent. Add 2 to 3 drops of aqueous barium chloride. barium chloride. Barium chloride. So barium chloride will form a white precipitate with the sulfate, with the sulfite, and with the carbonate. But we have said the sulfite, the carbonate are not there in from E, from the previous. We have said this one are not there. So if there is no white PPT, no white PPT. So what has remained, we are not going to, we will not repeat this one. Yet on the previous one, we have said they were absent. So you don't have to include them here. Here you only give the one which is remaining. Absent. This with this is a white precipitate. So there is no white precipitate. This one is absent. We are adding lead nitrate. Then a white PPT formed. A white PPT is formed. That confirms that there is a chloride ions inside. Chloride ions. You can also say bromide ion present. Thank you. Subscribe and share. Thank you.